So now we say that the second derivative is 0 or undefined. Well, it's 6x. When is 6x 0? When x is 0. Exactly, that's the only solution. It happens that we already had it here. Like before, we need to determine the sign of the derivative, this time the second derivative. So in 6x, plug in a number to the left of 0 and tell me the sign. I don't need the number, I just need the sign. And in 6x, plug in a number to the right of 0 and just tell me the sign. I don't need any number, just a sign. What do I put here and here?
Negative.
Of course. And
positive.
Excellent. So now here's a discussion. When the second derivative is negative, the function does not hold water. It's concave downward. When the second derivative is positive, the function is concave upward. And now let's analyze a little bit more what really happens here and what type of point now is 0, 0. Not 0, 0. The points are with the y variable, right? 0, 0. What type of point is that? When the function changes concavity, at this point 0, 0, the function has an I know this
point of inflection.
Inflection point, an IP. Awesome. Awesome. Okay, so let's analyze a little bit this, and then we are ready to graph. Now we are ready to graph this. I need to add a couple of things like the x and y intercepts, and we determined the limits, but we need one more thing, just the x and y intercepts and symmetry. But I just want to analyze what happens. So let's say a function opens down, then it has a point of inflection, and then opens up. This is not the function. We're going to talk about it, or we're going to graph it in a minute. But here's what happens. So this is the IP, inflection point. It changes concavity from opening down to opening up. Okay, so notice what happens here. This is the function, so I'm going to draw a few tangents. Here's one, here's the other, here's another, here's another. After the inflection point, I'm going to use a different color. What color should I use? This one. Okay, so let's look at the red portion. So the function has, it opens down. It's concave downward. What can you say about the slope of the tangent line? So this is the first tangent line, this is the second tangent line, this is the third tangent line, and this is the fourth tangent line. What happens to the slope of these tangent lines? Are they increasing or decreasing? So would you like to walk on this line, or would you like to walk on this line? When you go on a hike, you want to walk on this, or you prefer walking on this? So is the slope increasing or decreasing when the function is concave down?
Decreasing.
Yes, it is decreasing. So for concave down, the first derivative, which is the rate of change, is decreasing. Awesome. Let's look at when the function is concave upward. So here's the first rate of change or slope of the tangent. Here is the next one. Here is the next one. What happens to the rate of change, which is the derivative, the first derivative? What happens to it? Anyone? Would you like to walk on this slope, or would you like to walk on this slope?
Increasing.
Yes. So keep in mind that the rate of change is decreasing when the function is concave downward, and it's increasing when the function is concave upward. Why is this important? Why is it important to know that the rate of change is increasing or decreasing? Here's an example. Let's say, because it's a rate of change to measurement units, let's say you have a salary per year. Would you prefer to be at this point, or would you prefer to be at this point with your salary per year?
Increasing.
Yes, exactly. You prefer this because you want your rate of change, the salary, to increase at a faster rate, right? Increasing. But here, and also faster and faster. But here, it's decreasing. So the rate of change is decreasing. So at this point, you are getting 5% increase per year. But at this point, you're getting a 2% increase per year. And at this point, you may get 1% increase per year. So that's why it's important to know if the rate of change of a function is increasing or decreasing. You don't want to be here because your rate of change decreases. You want to be anywhere here when the rate of change is accelerating. Okay, so the last thing I wanted to do here is the x and y intercepts. We always need the x and y intercepts, and we also need symmetry. You can say, why do I need symmetry? Well, if we know the symmetry, if I know that the function is symmetric, for example, I'm going to talk about symmetry in a minute. So if I know that the function is symmetric with respect to the y-axis and I graphed this piece, I don't have to look anywhere else. I know it's symmetric with respect to the y-axis, fine. All I have to do is just graph the other side symmetric. So I will refresh your memory on symmetry in a minute. But I would like to discuss x and y intercepts. Anyone first? So anyone remind us, how do we get the x-intercept and how do we get the y-intercept? We discussed this in chapter R at the beginning of the semester. How do we get the x-intercept? How do we get the y-intercept? For any function, not just for this one. Anyone remembers how we get the x and y-intercepts?
Set y to 0.
Excellent. So this is when y equals 0. Okay. So x to the third minus 27x is 0. We pull out an x, and we have x squared minus 27. We have to get 3 solutions. The degree is 3. 3 solutions. And we get x equals 0 from here. And x squared equals 27, and we take the square root. So we have, remember, 2 solutions coming from here. One is the square root of 27, which I need to approximate, and the other one is negative the square root of 27, which I also need to approximate. So in the graphing calculator, since it's just a number, I'm just going to do this, the square root of 27, And I got 5.2 approximately. So 5.2 and negative 5.2. Okay. Sorry, Mike, I have to mute you. Sorry, because of the.
Oh, yeah.
That's
Sorry.
okay. That's okay. So I have to plug the in, and of course, y-intercept is when x is 0. We determined that y would be 0. That was determined already. So I have to fit these in the table. 5.2, 0, and negative 5.2, 0. Right? The x-intercept. Good. Now I have all the information I need to graph this function. So here's how we do it. Okay, I'm going to move on to, do I have enough space here? Maybe I do. Okay. So the point I'm making is I don't need any information, nothing else but the table. Yes, I promised to talk about symmetry. I'll come back to it in a moment. I don't care to look anywhere else. Everything else is gibberish at this point. That's all I need. So here it is. First, I start with the points that I have. Negative 5.20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the other one. Then I have negative 3, 54. So this is negative 3 here. 54, I'm going to say 10, 20, 30, 40, 50. 54. 0, 0. 3, negative 54. 1, 2, 3, 4, 5. And that's all I have. Okay, so now, from negative infinity, opening downward, increasing to this point. Okay, fine. Continues to increase, still opening downward to the relative max. It starts decreasing, still opening down till the point of inflection 0, 0. Where it changes concavity, decreasing, changes concavity, and coming down to a relative minimum. Continues to open upward, increasing to the point of x-intercept. Still increasing, still opening upward, still increasing towards infinity. Step by step, the table told me, I had to look everywhere, told me how to graph this function. And this is f of x equals, what was it? Who knows? Who cares? We do. So that's the graph. And the table gave us everything. Coming from negative infinity, crossing the x-axis at this point, increasing to the relative max, still opening down at all times so far, till the point of inflection, 0, 0, where it changes concavity, opening upward, coming down to the relative minimum, crossing the x-axis again here at 5.2, 0, and going to infinity. Any questions? Any questions on how to use the table? See, if I don't have all the information summarized and it's on 2 or 3 pages, I will not know how to put it together. What does this mean? It doesn't mean anything. But once I have everything summarized on the table, every step in the table told me what to do from left to right. It's an invaluable piece of way of summarizing the information. Okay, moving on. I want to talk about symmetry. So I'm on page 4.